Hey friends, welcome back to Civil Engineering Mastery. We analyze the structure in order to get the internal forces developed due to the application of external loads. This is the major function of the structural analysis. We need to find out the internal forces developed in the structural elements. So the major internal forces are bending moment, shear force and deflection. So in this video, let's discuss about simply supported beam with different load cases. What are all the bending moment, shear force, deflection formulas for simply supported beam with different load cases, and how do we make the shear force and bending moment diagram. So let's discuss all these things in detail. So without delay, let's begin now. First, let's start with the simply supported beam with point load at center. As you can see, the point load is acting at the center of the beam. The length is L. So in this case, we will be getting the shear force diagram like this. The force has to go up, that is RA, reaction at A and reaction at B. So when the load is acting, it comes downward and then again it goes and then again up. So RA will be W by 2 and RB will be W by 2. So here you need to consider the sign conversion. Upward direction, downward is negative. So this is the sign conversion for shear force here. So this is upward, so it is positive W by 2, load divided by 2. This is coming downward and then it is negative. Downward means negative. So RB is negative W by 2. This is all about the shear force diagram. Next one is bending moment diagram. So if you take the moment A, here at this end it will be 0 and the bending moment will be maximum at the midpoint, and then at this end also the bending moment will be 0. Shear force will be maximum where the bending moment is 0. As you can see, shear force will be maximum at the support here. So at this point the bending moment is 0. So bending moment at MA is 0, bending moment at MB is also 0, and bending moment at MC is WL by 4 kilonewton meter. Next one is deflection. So deflection, this is the deflection. The formula is WL cube by 48 EA. So when the load is acting at the center of the beam, the deflection formula is WL cube by 48 EA. Here W is the load, L is the distance, E is the modulus of elasticity, I is moment of inertia. Second case, let's discuss about the point load at varying distance. So the point load is acting on the beam at varying distance. See here, the total length of the beam is L and the load is acting at a distance A, and here the remaining distance will be B. So this is the case, the point load is acting at varying distance. Let's look into the shear force diagram. See here, it is going upward and then again it is coming downward and again it is RB. The reaction is RB here. So at RA, the shear force will be W into B divided by L. Since the load is acting at varying distance, the shear force we need to consider like this. So RA will be WB by L, RB will be WA by L. Next, let's look into the bending moment diagram. Here at this point, bending moment will be 0. Similarly, MB also 0, and bending moment will be maximum at the point of application of load. So at MC, the bending moment will be WAB divided by L kilonewton meter. Next one is deflection. Deflection is similar to the previous case, but the formula will be different. WL cube by 48 EA. Along with that, we need to add this 3A divided by L minus 4 into 2 by L cube. Next case is simply supported beam with 2-point load. See here, the load W is acting at a distance of L by 3, and then again the load W is acting at a distance of L by 3. So we are dividing the beam into 3 parts and the load is acting at 2 points. So in this case, the shear force diagram would look like this. See, it is upward, the load is going upward, and then again it is coming downward. First the reaction is upward, it is positive W kilonewton, RA is positive W kilonewton, and then it is downward. The load is acting downward, so it is downward, and there is no load, so it is a straight line, and then again downward and then no load, and again it is upward. So here it is positive and this is negative. RB is negative. RA is positive W kilonewton, RB is negative W kilonewton. Next, let's look into the bending moment diagram. So MA is 0 and MB is 0, and then see here the bending moment will be maximum at the point of application of load. So here it is maximum MC, and then again it is straight line since there is no load, and again there is a load which is coming at this point. So here we have MD, bending moment over here. So MA and MB will be 0 and MC and MD will be W into L by 3, load into distance. So that is the bending moment value here, W into L by 3 kilonewton meter. Next one is deflection. So deflection formula for 2-point load in simply supported beam is 23 W L cube by 648 EI. Next one is uniformly distributed load. The load will be acting per meter length. That is why it is given as W per meter. Let's look into the shear force diagram. The shear force diagram will be different for uniformly distributed load. Till now we have discussed about point load which is acting on the simply supported beam. So the shear force diagram was different. Here the shear force diagram will be different. RA, and then for uniformly distributed load it comes like this, and then again RB. Since it is a uniformly distributed load, we need to consider length as well to calculate the shear force. So W into L divided by 2. Because the load is acting per meter length, so that is why we need to consider the length over here. The sign conversion is similar, upward positive, downward negative. So RA is W positive WL by 2 and RB is negative WL by 2. Next, let's look into the bending moment diagram. At MA it is 0, MB is 0, and bending moment will be parabolic in uniformly distributed load. So at the midpoint it will be maximum. The formula is WL square by 8. Next one is deflection. To calculate deflection, the formula is 5W L power 4 divided by 384 EI. W is the load per meter, and then L is the length of the beam, and E is the Young's modulus, I is the moment of inertia. Last one is uniformly varying load. Here also the load will be acting W per meter. Let's look into the shear force diagram. Shear force diagram will be little different. So the shear force diagram will be little bit curved for uniformly varying load. Upward positive, downward negative. The sign conversion is same. RA is positive WL by 4 and RB is negative WL by 4. Next one is bending moment diagram. MA and MB are 0, and in the midpoint the bending moment will be maximum. So MC is WL by 6 kilonewton meter. For uniformly varying load, to calculate the bending moment, the formula is WL by 6. And then deflection. To calculate deflection, the formula is WL cube by 60 EA. So friends, if you want the similar kind of formulas for bending moment, shear force and deflection for fixed beam, kindly let me know in the comment so that I will make another video for that. I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. If you really like the content, hit the like button. Also share it with your friends, and don't forget to subscribe the channel for more videos. Thank you for watching.